Okay, so it is day 21 of Algebra 2, and it is Monday, April 28th. So I'm just going to write that on these worksheets. Algebra 2, and is day 21, Monday, April 28th. Same here. Let me grab it. Okay, let's do both of these. Now we're going to look at the worksheet with the spinners first, the little rainbow circles at the top. And on this worksheet, we are looking at the probability of independent events, not dependent, which if we recall, that just means that the probability of the two events do not affect each other. The total number of outcomes does not change, unlike dependent events. So, got my pages titled. Let's look at number 1. So, on the first question, we are asking, what is the probability that we will spin an even number on the number spinner and the probability of spinning a red A on the rainbow spinner? So, before we find the probability of both, how do we find the probability of spinning an even number on the first spinner? Okay, 2, 4, 6, and 8. Those are all my even numbers. So how many evens are there? 4. And how many numbers are there on the spinner? 8. There are 4 even numbers. Let me use a color. And there are 8 numbers on that spinner total. So we've got that fraction. Now, what do I need to find next?
The probability of spinning A?
Yes, the probability of spinning a red A. So, there's only one red A. How many options are there on the rainbow spinner? There's 6. So, I'm going to write 1 out of 6. So, I have my 2 probabilities. How do I find the probability of both of these happening? We just multiply them.
Is it easy to break down 4 over 8 though?
To simplify it?
Yeah.
You do not have to, but you absolutely could. So instead of 4 over 8, you could have reduced this down to 1/2. Yes. So how do I multiply fractions?
Straight across.
Straight across. 4 times 1 is 4. 8 times 6. That is 48. Okay, so 4 out of 48. If I wanted to simplify this, let's see, what would our simplified fraction be? 2 over 24. Yes, or 1 over 12. This step is optional. You don't have to simplify, but sometimes it helps us to see the true probability in fraction form. So 1 over 12, how do I find my decimal? Perfect, 1 divided by 12. And that gives us 0.083 repeating. Could I get this decimal by doing 4 divided by 48 as well? Yes, you could. That's why you don't have to simplify the fraction. It's just another extra step. Because even if you don't simplify, you will get the same decimal, you'll get the same percentage. So now that I have my decimal, what's my percentage? 8.3%. I just moved that over 2 spaces. 8.3%. And that 3 repeats So the probability of spinning an even number and landing on a red A is 8.3%. Awesome. Awesome, awesome. Okay, let's look at number 2. What is the probability of spinning a number bigger than 3 on the rainbow or on the number spinner and then spinning a yellow C on the rainbow spinner? So, how do I find the probability of spinning a number bigger than 3? There's 7 of them. How do you find that number? Let's see. I need to count and see how many numbers are bigger than 3 on that spinner. So I have all these numbers: 1, 2, 3, 4, 5, 6, 7, and 8. These are all my numbers. Is 1 bigger than 3? No. Is 2 bigger than 3? No. Is 3 bigger than 3? No. Is 4 bigger than 3? Yes. How about the rest of them? Yes. These are all bigger than 3. So, how many numbers here are bigger than 3? 5. 1, 2, 3, 4, 5. We're looking for the total amount of numbers that are bigger than 3 that we could spin. So, we have 5 numbers that are bigger than 3 out of how many total? Still 8. Perfect. 5 out of 8. Okay. What's the probability of spinning a yellow C on the rainbow spinner? Just 1 yellow C out of how many options? 6. Okay, so here's my probabilities for both of the events. How do I find the probability of them both happening? We're going to multiply. Okay, so 5 times 1 is 5. 8 times 6 is 48. What's my decimal?
0.104.
Perfect. 0.104. And my percentage? 10.4%. Move it 2 spaces. 10.4%.
So that threw me off because at first I started doing them separate. So the independents always get multiplied.
Yes.
It's only the independents that get multiplied together like that.
So the dependents also get multiplied. The difference is that independent events, the bottom numbers are not changing because they don't affect each other. When we get to the dependent events here, it's like we're starting with a total of 25 marbles. That'll be our number on the bottom. But after we take 1 marble out, then the number changes on the bottom. Yes. Yes. Okay, now that's a good question. Any other questions before we go to number 3?
That's why I forgot to multiply them.
I gotcha. Okay, let's look at number 3 now. So number 3 says, what is the probability of spinning an odd number on the number spinner and then spinning a blue E on the rainbow spinner? So what's the probability of spinning an odd number? 4 over 8. There's 4 odd numbers. 1, 3, 5, and 7. And there's 8 total. Okay, and then what's the probability of spinning a blue E? 1 over 6. We'll multiply them just like the other 2. And you're going to get the same answer as number 1. 4 times 1 is 4. 8 times 6 is 48. If we wanted, we could simplify that to 2 over 24. It still could be simplified to 1 over 12. Our decimal, same as on number 1, 0.083 repeating. 0.083 repeating. And then one last thing, what's our percentage?
8.3 repeating.
Perfect. 8.3 repeating percent. Beautiful. Okay. So these questions were all independent events. No matter what number I land on, that does not affect how many options I have to land on the rainbow spinner. The two spinners don't affect each other. That's why they are independent. Yes?
Is the repeating required?
It's not required. If you don't put it, I will not count it wrong. Good question. Okay. So, any final questions on this first worksheet? Okay, if not, we're going to go ahead and move on to the dependent probability worksheet. And this one's going to be a little bit different. Okay, so now we have just one big item. It's a bag full of marbles. Okay, and there are 25 marbles total. And then I've just listed out the number of each color marble we have just to help make it a little easier to solve these. So on number 1, I wrote, what is the probability of drawing a pink marble, then without putting it back, drawing a purple marble next? So these will affect each other because once I pull out a pink marble and I don't put it back, I don't have a total of 25 marbles in the bag anymore. There are less. There are 24 marbles in the second instance. So let's start with number 1 and just think about the possibilities. I want to know the probability of drawing a pink marble and then drawing a purple marble without putting that pink one back. So how do I find the probability first of drawing a pink marble? 2 out of 25. Good. There are 2 pink marbles. There are 25 marbles total. So 2 out of 25. Now here's where it gets different from the other worksheet. We're assuming that we picked a pink marble and we did not put it back. When we find the probability of picking a purple marble, there are no longer 25 in the bag. How many are left? 24. So that becomes our new total on the bottom. Now, how many purple marbles are in the bag? 5. So 5 goes on top. And just like the other worksheet, we are multiplying them. And before we find the answer, because I did, it's been the weekend, we've forgotten things. We haven't looked at dependent ones in a while. Let's talk about some of the different things we wrote that were not this, okay? Does anybody feel confident and want to tell me what they did to solve this that was incorrect? What's something you did wrong?
I put 5 under 25.
You put 5 and then 25, so you didn't change the 25 to 24. Who else did that? Did anybody keep it 25 on both?
I made it 23.
You made it 23. Okay. So we saw, there's 2 pink marbles. So we're assuming we're taking them both out. So it changes to 23. I bet you more than you just did that. I bet you more. Okay. Super easy to forget how to do this, but all we do is take the 1 out. We've got 24 on the bottom now. So whenever I am finding the probability of both of these happening, we're just multiplying like in the last worksheet, straight across. So what is 2 times 5? 10. And 25 times 24? 600. Woo. Okay. We could simplify this, but let's go ahead and get to the decimal part. So 10 divided by 600, what does that give us?
0.016 repeating.
Perfect, 0.016, and that 6 repeats. Okay, and our percentage?
1.6.
Perfect, 1.6 repeating percent. So there's a very small chance of this happening, only about 1.6%. Very small chance.
I got that answer.
You got the answer?
Yeah, but I still put 5.5 over 5.
Did you do 2 over 24?
No, I did 224. 225.
Interesting. What was your fraction that you got?
10 over 625.
10 over 625. Let me see how that would change. Maybe it's very close.
But it's 16.0.
Ah, okay, so yours was so close. It's just that it wasn't repeating. Wow. Well, technically, you would have got the percentage right still. That's funny. It's pretty close. Pretty close. Okay. Let's look at number 2. What is the probability? We're starting all over. We got 25 back in the bag. Okay. Of picking an orange marble and then, once that marble's gone, picking a blue marble.
So you don't turn it back. So it's the same direction, but different color.
Yes, exact same. So, there are 25 marbles. How many orange do I have? 5. That's my top number. And on bottom, there's 25 total. Okay, so now assume that we did draw an orange marble. I didn't put it back. Yes, there are 6 blue marbles. And now that one is gone, there are 24 left. So I'm multiplying 5 over 25 times 6 over 24. So let's see. 5 times 6 gives me 30 on top. And the same thing on the bottom. 25 times 24 will give us 600. Okay. So tell me when you get to this point, what is my decimal?
0.05.
Perfect. 0.05. So what would my percentage be? I heard 2 different things. Say it again. 50%? Did anyone get something different? 5% or 50%? So which one's correct?
You have to add the 0.
So we add a 0 if we go past the number. Like here, I'm going to write in these boxes to show my spaces. I have 0.05. Okay. If I move it 1 space, now I have 0.5. I move it 1 more space, now I have 5.0. It would be 50 if I moved it 1 more, and now the decimal is after the 0. But we're only moving 2 spaces, so it actually will be 5%. 5%. If you wanted to be real accurate with it, you could say 5.0%. Both are fine. Okay. Perfect. Well, that's perfect too. Awesome. All right, there we go. 5% or 5.0. Good. Okay. 2 more. Look at number 3. Now we're doing red, then green. What's the probability of pulling out a red marble the first time? Good, 3 out of 25. And then what's the probability of pulling out a green next? 4, good, out of 24. Okay, so 3 times 4 is 12. 25, 24, 600. Same as the other two. Okay. And this one's going to be similar to number 1 just because the number is so close. 12 divided by 600. What'd you guys get for your decimal? Perfect. 0.02. And our percentage? 2% or 2.0%. Both are correct. Very nice. Okay, one last problem. One last problem. Number 4. What is the probability of drawing a purple marble? Perfect. 5 out of 25. And then orange. Perfect. 5 out of 24. Okay. And 5 times 5 is 25. 25 times 24 is 600. Okay, and 25 over 600, let's see what that is. Did you guys get? Perfect. 0.041. 6 repeating. 0.0416 repeating. Okay. And what would our percentage be? Perfect. 4.16 repeating percent. If you got rid of the 6 repeating, you could have either wrote 4.1 or 4.2. If we rounded it properly, it would be 4.2, but I will not count 4.1 wrong. That is just as good. Okay. There we go. We just did a bunch of probability problems. So these 2 worksheets, what I would like you to do is write your names on them. Okay, write your names on both of them. And I'm going to put a stapler over here. I want you to staple them together and turn them into me. Because instead of having you take a quiz over this, I'm going to count this as our end of unit assessment. We did it together. They're good to go. Staple it, turn it in, make sure your name is on it. And once you do that, we're going to go ahead and take our break. And when we come back from break, we're going to start something new. All right, so we are back from break. I just gave everybody one of these. And I am going to title this so I don't lose it, so I know what it is. This is Algebra 2. And now we are in Unit 3. And we're going to talk about systems of equations. Okay. So when we are talking about systems of equations, this is assuming that we have more than one equation present. We're going to start just by, again, brushing up on our equation solving skills, making sure that we do understand all of those basics before going to things a little more complicated. So first, I want to write up here y equals mx plus b. Is this equation familiar to any of you? Some yes, some no. That is okay. We're going to make sure that we get familiar with this. This is the slope-intercept form of a linear equation. So a linear equation is an equation that when we put it on a graph, it makes a line. Linear, it means it looks like a line. So this is the form that we normally see these equations in. Now, in this form, we have two things that we need to be able to recognize. The first thing is that we have an M here and that we have a B here, and then we have a Y and an X. My Y and my X, I'm not ever going to change. There will never be a number there. It'll always be Y equals a number, X, plus a number. Does anybody know, without me telling you, what the M in this equation stands for? Slope. What on earth is slope? We're going to talk about it. For now, let's just get these labeled so that we have them as a note. So M means slope. It's going to tell us how steep our line is when we draw it. And does anybody know what the B is? Y-intercept. Good. So Y-intercept. Okay. So we have a slope, we have a y-intercept. Okay. So y-intercept might sound familiar to you because we labeled y-intercepts on our last quiz whenever we had a parabola. Does anybody remember what we define a y-intercept as? Yes, it's where does my equation, where does my line touch the y-axis, the axis that goes up and down, the y-axis. So the y-intercept touches the y-axis. I'm going to write that down as a little definition just so that we can remember what each of these things mean. So the y-intercept is where the line touches the y-axis. I'm going to write y in blue here. Okay. The y-intercept will also be our starting point. Now, slope tells us how steep the line is. If it's a very large number for the slope, it's going to be a super steep line. If it's a small number, like a fraction, it will be less steep. It might be more of a gradual decline or incline. So I'm going to say for slope, how steep the line is. So we have our equation, y equals mx plus b. M is our slope, b is our y-intercept. So I'm going to have us start with our first example, and I'm going to show you how we graph an equation. Before I do that, can I move this, or is anybody still copying this part down?
What's going on, man?
All right, so now let's look at our first example. So underneath this graph here, I'm going to put a number 1, and I'm going to write an equation. This equation will be y equals 1/2, 1/2, x plus 2. Okay, so y equals 1/2 x plus 2. So I'm going to zoom in on this, and the first thing we're going to do is point out which numbers mean which things. So remember, I have y equals mx plus b. My m is my slope. So since instead of an m, I have 1/2 written, this 1/2 will be our slope. So let's circle the 1/2 and write slope underneath. So y equals mx plus b. B is our y-intercept. Instead of b, we have 2. So in this problem, 2 is the y-intercept. And I'm going to write an abbreviation there since intercept is a long word to write out. So we have our slope and our y-intercept. So there's only 3 very short, simple steps to graphing this equation. What this means, essentially, is that whatever value I choose for y, for example, let's say I chose 0 for y, that my x value, or I mix that up. Okay, whatever value I choose for x, my y is going to be half of that plus 2. I can explain that more here in a moment. But here's how we graph this. We begin with the y-intercept. Our y-intercept is 2, positive 2. So I'm going to write step 1, graph the y-intercept. So if my y-intercept is positive 2, and I know that the intercept is where I'm touching the y-axis, where do you think I will graph this point? What would my first point be? 0 on the x, 2 on the y. I need to be touching 2 on the y-axis. My y-axis goes up and down. So we've got 2 as our y-intercept. Now we have a slope of 1/2. Does anybody know how to use slope to find another point?
You go up 1 and over 2.
You do. So slope is defined as, it tells us how steep it is. So these numbers are going to give us a direction. They're going to tell us how far up do I need to go, how far over do I need to go. So slope can also be written as, we're going to write rise over run. Rise tells us how far up or down to go. Run tells us how far to the right to go. We're pretty much always going to go to the right for run. So, step 2, use slope, rise over run, to find a second point. Okay. So because our slope is 1 over 2, and slope is rise over run, my rise, how far up will I go, will be 1. My run will be going over 2. So I'm going to move up a little.
Will the top or the bottom number ever be like negative?
It could be, yes. And we'll talk about one of those next. So starting here, we just graphed the y-intercept, and we want to make sure that we start from that point. The y-intercept is our starting point. Okay. Now our slope is 1 over 2. So I'm going to go up 1. So instead of being on 2, I'm now on 3. And then over 2 spaces, I go over 1, 2. And that would be my second point right there. And sometimes what I find helpful is whenever you move spaces, maybe mark them, saying I went up 1, I went over 1, 2. So I went up 1, and I went over 2, because my rise is 1, my run is 2. So now I have 2 points on my graph. We only need 2 points to make a line. So here's where we just grab a ruler, which all of you should have rulers at your tables. If not, there are tons of extras over by the turn-in trays. And we are going to make sure that when we connect these dots, we make it as perfect and precise as possible. So something that we can do to make sure it's super precise is on a line, our slope is consistent no matter what point I start at. I'm always going up 1 over 2, up 1 over 2, forever and ever and ever. If I want to make sure that my line is super accurate, I could keep counting that slope just to make sure I go through all the right points. Up 1 over 2, well, let's do it again. Up 1 over 2, up 1 over 2, up 1 over 2. So I need to make sure my ruler goes through all these points when I connect my dots. Now I know my line is going to be accurate, or as accurate as I can make it. And there's my line. And we just put arrows on the ends of that line. Okay, there it is. We graph the line. So really, all you do, find your numbers. Which one's the slope? Which one's the y-intercept? First, we graph the y-intercept. Then we find another point with the slope. And then we just connect the dots. So I'll leave this up for a moment, and then we're going to try another one together. All right, number 2 over here. Now let's look at y equals 3 over 4x. And this time let's do negative 3 over 4x. We're going to have a negative number on our slope. Negative 3 over 4x plus 4. So my second line, y equals negative 3 over 4x plus 4. So first we want to find which numbers are our y-intercept? Which number is my slope? Since we're going to graph the y-intercept first, let's find that first. What number in this equation tells me my y-intercept? 4. Positive 4. So I'm going to circle that and label it as my y-intercept. And which number is my slope? -3 over 4. Good. This is my slope. Okay. So following the same steps as before, the first thing we'll do is graph the y-intercept. So where does that first point go? +4 on the x or the y-axis? Y-axis. So we're going to go up 4 to start. Okay. Now, adding a negative number into my slope makes things a little bit different. Our slope is what we use to find the second point. I'll start from 4 and I'll do my rise and my run. But now I have a -3. Say it again. Yes, yes. So I'm going to write down here rise and then run. And since my slope is -3 over 4, that means my rise is -3. In the last one, our rise was +1. Since it was +1, we went up 1. Now we have -3. So instead of going up 3, just like Alexis just said, we're going to go down 3 because it's negative. So I'm going to draw a nice little down arrow to help me remember that. And then what's our run? 4. And our run is positive, so we're going to move towards the positives in the x direction. We're going to go to the right, just like in the last one. So -3 is my rise, my run is 4. I'm going to go back up to my graph, and from here, we are going to find our next point. Now, do I start from 0 or from 4? 4. This is your starting point. My rise is -3, so I'm going to go down 1, 2, 3. My run is 4, so I'm going to go over 1, 2, 3, 4. So I went down -3, and I went over 4. Okay, so my next point will go right where I landed, right here. We're lining up with 4 on the x-axis, and we're lining up with 1 on the y-axis. So we've got our 2 points. Now we just connect the dots. And let's see. 1, 2, 3. There we go. And I'll put arrows on the ends of my line to show that this line goes on forever in both directions. And that is the graph of y equals -3 over 4x plus 4. Very nice. So, now that we have graphed 2 lines together, I want to know visually, by looking at these graphs, what do we notice is different about how these lines look? Yes, one of them is going up, one of them is going down. Okay, so in the first one, our line is going up, it's increasing. This is because our slope is positive. When we have a positive slope, that slope is going to go uphill like this. So underneath here, I'm going to write positive slope. Positive slopes go up. In number 2, my slope was negative. So that's why it goes downhill. It's decreasing. So this is a negative slope. Okay. Negative slopes go down. Positive slopes go up. Okay. All good things to note. All good things to have in your note. So let's do a little more practice with this. I'm going to give you another equation. So we'll label this number 3. And now let's try y equals 3x minus 5. Y equals 3x minus 5. What should I do first? Ooh, yes. Oh my goodness. I'm hearing multiple things and they're both correct. So my 3 is my slope. And for slope, just like we did in the last 2 problems, we need a rise and we need a run. Since there's just one number here, our rise would be 3, but since there's not a number on bottom, how do we know what our run is? So exactly like you just said, 3, since it's a whole number, we want it to be a fraction. And any whole number as a fraction, you just put a 1 under it. 3 over 1 is the same as 3. So when there is no run, our run is 1. So really our slope is 3 over 1. Okay. What's our y-intercept? -5. Now I have -5. If it was +5, it'd be positive. Since it's minus, this is a -5. So I'm going to include that minus sign. So that's my y-intercept, -5, and my slope is 3 over 1. So if I want to graph this line, where do I start? -5 on which axis? The y-axis. Good. My y-intercept is -5. So I'm going to start at -5 on the y-axis. Okay. Where do I go from there? Up 3 over 1. Our slope is 3 over 1, so we go up 1, 2, 3, go over 1. And there is our second point. So we have our 2 points. All that's left to do is connect the dots. And while we're connecting the dots, is this a positive slope or a negative slope? Positive. We can tell by our equation, there's no negative on the 3. We can also tell by the way the graph looks. Go through these points. We can tell this is positive because when we go from left to right, that line is going up. So this is positive. Just going to write that on there. Okay. There we go. And let's do one more together, and then I would like to give you some to try on your own. Make sure that this stuck in our brains. And then we're going to start talking about a system of equations, which I promise is not much harder. It's really just two of these on the same graph. So, one last equation. Let's try y equals negative 5x plus 4. Y equals negative 5x plus 4. What do I do first?
You automatically put a 100 next to top.
Yes, yes, that's a great habit to get in. If you see that your slope is not a fraction, negative 5, go ahead and start by turning it into 1. We're going to make this negative 5 over 1. That way I know how far down or up and how far over to go. Negative 5 over 1 is our slope. Great place to start. And what else do I need to identify? My y-intercept, which is what? 4. Good. It's always going to just be the number at the end of the problem. So 4 is my y-intercept. Okay. So where do I start?
Putting 4.
So 4, positive 4, negative 4, x-axis, y-axis. Positive 4 on the y. Good. So I'm going to start with a point right there at 4 on my y-axis. And where do I go from there? Perfect. My slope is negative 5. I will go down 1, 2, 3, 4, 5. Yes, you do count this as a point whenever you cross an axis. This is not just one jump. This is 2 spaces still. Might seem silly to some of you, but you would be surprised how many would not count that as 2 spaces. So we went down 1, 2, 3, 4, 5. Then what? Over 1. Always to the right. So I went down 5 because my slope tells me that it's negative 5 over 1. And where we ended up was right here at 1, negative 1 for our second point. Now notice for these last 2 problems, since we didn't have a fraction as our slope, these lines are much steeper. They don't go up as gradually. There's more space in between each point because the slope is bigger. So whenever you have spaces that are much larger between points, it can be a little bit tricky to get your line super accurate. This is another great example where it would be helpful to count the slope again and give yourself another point to go through. Not necessary, you don't have to, but I think sometimes it helps with accuracy. So I went down 5 over 1. I'm just going to do that again. 1, 2, 3, 4, 5 over 1. There's another point. Now I can just be even more accurate when I line up my ruler. So I'm going to take my ruler and make sure that it touches all 3 of these points. There we go. And I'm just going to trace through them. And that is my line. Just like that, super steep. Is this a positive slope or a negative slope? Negative. First of all, there's a negative number where the slope is. Second of all, it's going downhill. This is a negative, like a super negative slope. So, all good things to note. So, now that we've done these few examples together, I am going to give you 4 equations that I would like for you to try to graph on your own on the back. If you mess up or something, no big deal. I printed off a ton of this graph paper up at the front of the room. If you need extra or if you just would like to have some on hand, you can take as much as you need. I can always make more copies. But I'm going to scooch this up a little and write some equations for you to try. So that was number 4. I'm going to write 5, 6, 7, 8 to try on your own. We'll do y equals 4x minus 2. Y equals negative 2 over 3x plus 4. Y equals 7x plus 6. And y equals 4 over 5x minus 3. Okay, so 4 new equations for you. Try to graph these on your own. If you have questions or need a little help or guidance, feel free to work with each other. I think working together is a great way to get better and learn. And one of the best ways to learn something really well is to teach it. So you guys can help each other out. And I'll set a little timer and then we'll look at these together. So pause that for now and I'll put a little music on. So first, we need to look at the graph of y equals 4x minus 2. So let's pull this up, and I'm going to rewrite the problem. 5, we have y equals 4x minus 2. What do we do first?
Place a dot on negative 2.
Perfect. Dot on negative 2 is our first step. Yes, that's our y-intercept. Okay, and what do I do next?
You're going to put the 1 under the 4.
Perfect. My slope is 4. I'm going to make it 4 over 1.
4 spaces and then over 1.
Yes, up 1, 2, 3, 4 over 1. There I go. Perfect, perfect. So, I'll mark that 1, 2, 3, 4, 1. I could do it again if I wanted to. Okay, and my last step is to connect the dots. That's all we do. Okay. There we go. And there is our first line. Y-intercept at negative 2. We went up 4. We went over 1. Hello, hello. All right. Number 5. Let's look at the next one, number 6. Now I have y equals negative 2 over 3x plus 4. Negative 2/3 x plus 4. What do I do first? Find my y-intercept. Good, it's 4, positive 4. So we're going to go to 4 on the y-axis right here. What's next? Perfect. We're going to go down 2 over 3. So here's 1, 2 over 1, 2, 3. That's my second point. We found that using our slope. Perfect. I could continue that if I wanted to. I could go down 2 again, over 3 again. Don't have to, but I could. And we just connect the dots. Okay. Looks good. Awesome. Okay. Let's look at number 7 now. I'm going to go ahead and write that one underneath. Number 7 was y equals negative 7x plus 6. This one is got a pretty large slope compared to the others. Okay, negative 7x plus 6. What do I do first? Find my y-intercept 6 on the y-axis. So I'm going to go up to positive 6 right here. There we go. And what do I do next? Yes. Negative 7 is my slope. I'm going to put it over 1 since it is a whole number. So on my graph, where do I go from the starting point here? Go down 7. So I'm going to count 1, 2, 3, 4, 5, 6, 7. We'll end up at negative 1 on the y-axis, and I go over 1. So my second point is right here. Okay, we went down 7, and we went over 1.
Whenever it's negative, I keep going negative.
You keep going negative. What do you mean?
Like, whenever it's negative, instead of going right, I go left.
Okay, so this is a good way to be careful on that. I'm going to grab a separate graph and show you. So I bet somebody else in this room, at least one other person, is having the same problem. When you have a negative slope, instead of going up, we go down. But for our run, we're still going to the right one and not left. Moving this to the side, I'm going to show you something real quick. When we have a negative number on top for our slope, like I'm going to say negative 3 and then positive 4 versus negative 3 or negative 4. Okay. So here is a good way to kind of remember which direction we're going for each of these things. First of all, in the y direction, up and down, we know that up is where we see the positive numbers, starting at 0, 1, 2, 3, 4, 5, 6, up to infinity. When we have a negative number, it's because we're going down. Below 0, we have negative 1, negative 2, negative 3, going on and on until negative infinity. Now, in the x direction, we have positives to the right. We have negatives to the left. My top number is negative. My bottom number is positive. So, since my 3 is negative, that means I'm going to go down. because in the y direction, my negatives go down. My 4 is positive. I'm looking at my x's, so I would need to go to the right still. Now here's where something might be different. If I have a negative over a negative, I'm going, yes, down because it's negative, to the left because it's negative. Now, because we have a negative over a negative, what happens when we have a number like this? A negative divided by a negative is?
Cancel out.
It cancels and it becomes positive. Let me show you how this will look. Let's say I start, I don't know, right here at 4. We're just going to start at 4. And first I'm going to do down 3 to the left 4. 1, 2, 3. I went down 3. 1, 2, 3, 4. If I go down and to the left instead of down and to the right, you'll notice that my 2 negatives will cancel out because this is a positive slope, isn't it? The line is going up. So if you have a negative number as your slope, that line needs to be going down. So if you notice that you accidentally go to the left instead, and now your slope is positive, see, oh, hang on, let me grab this. Our positive slopes increase. Our negative slopes decrease, they go down. So this is the negative 3 over negative 4. It's actually positive 3 over 4. If I did negative 3, starting at 4, over 4 to the right, let me grab a different color for this. So let's say now I do this one. I go 1, 2, 3 down and 4 to the right. 1, 2, 3, 4. Now I have a truly negative slope because when I move from left to right, notice how when I draw my line, my marker moves down. Well, okay, I messed that up a little, but you get the idea. In order to have a negative slope, we're going down and to the right. If I go down and to the left, I'm actually making a positive slope. See that? So maybe that'll help, just being able to see it visually, help remind you not to go to the left. Just remember that since our bottom number is positive, we are going towards the positive numbers, right? Okay, so let's go back to the problems I had you do. Number 7 here, we have y equals negative 7x plus 6. We plotted our y-intercept at positive 6. We used our slope, negative 7 over 1. We went down 7. We went over 1. So now we just connect the dot. And we know we did it right because our line is moving downward for a negative slope. If our line is going up, we know we did something wrong. So there it is. There's number 7. Steep line. Okay. Right, it's not too bad. It's really like 3 little steps once you break it down. It's not too bad. And what was number? The third step is, yeah, connecting the dots. That's all there is to it. Okay, number 8. What did I do with that question? Okay, it is y equals 4 over 5x minus 3. Okay, how do I graph this one?
You have plotted dot on the y-axis of negative 3.
Perfect. Negative 3 is my y-intercept, so that's where I'm going to start. Negative 3 on the y-axis.
And you're going to rise 4.
Perfect. So I'm going to go up 1, 2, 3, 4.
Over to the right 5.
Perfect. Over to the right. 5. 1, 2, 3, 4, 5. And my next point will be right there where we ended up. So my rise was 4. I went up 4. My run was 5. So I went over 5. And we just connect the dots. Very nice.
And it's a positive slope.
And it's a positive slope. Perfect. Perfect, perfect. And we know we graphed it right because that line is going up. Positives go up. There we go. All right. That's not so bad, is it? It's not terrible. I think you guys can do that. Okay, so I am going to today let those worksheets we did at the beginning be our exit ticket. I just wanted to introduce this, kind of give us a little graphing review so that tomorrow we can get more into Unit 3 and start really talking about systems of equations. All we did here was graphing an equation. We're going to start systems tomorrow. So, if you came in late and have not completed these 2 worksheets, I wrote names on those people. I'll bring them to you, or you come find me. I've got them for you guys. And that's going to be today's exit ticket. Okay. So that is all. I hope you all have a good day. I'll see you tomorrow.